a 14.5 kg mass fastened to the end of a steel wire of unstressed length 1 meter is whirled in a vertical circle with an angular velocity of 2 revolutions per second at the bottom of circle. The cross-sectional area of the wire is this much, which is 0.065 centimeter square. Calculate the elongation of the wire when the mass is at the lowest point of its path. हमें गिवन है एक mass m which is 14.5 kg and this mass is attached to a steel wire and उस steel wire की natural length or unstressed length is 1 meter is given to us. Now this mass is rotated in a vertical circle. This mass is rotated in a vertical circle and frequency of revolution is 2 revolution per second. From this we can calculate omega which is equal to 2 pi nu. So my omega is equal to 4 pi radian per second. Okay, now we are also given that area of cross section of this wire A to be 0.065 centimeter square. Further, I can write it as 0.065 into 10 raised to power minus 4 meter square. Now we are asked that calculate the elongation of the wire when the mass is at the lowest point of its path. So when the mass will be at the lowest point of its path here in this vertical circle, if I redraw it as this is my wire, having a certain cross section which is given to us, and at this point of the vertical circle we have to calculate the elongation. So at this point the forces acting on the body or on the wire actually is force at the bottom point is weight mg of the block plus a centripetal force that is mr omega square. So on putting the values, the mass is 14.5 into 9.8 plus 14.5 into again the value of r, that is the length of the wire, which is 1 meter, into omega square. We have calculated the value of omega to be 4 pi. So omega square will be 4 pi into 4 pi. On solving this, the force acting at the lowest point will come out to be 2430 Newton. Now we know the Young's modulus Y is equal to stress upon strain. Further, I can write it as stress is force acting on the unit area and strain is change in length. This will be divided by original length which will come on the numerator. I can write here as L. And we know on rearranging I will get delta L to be FL by AY. we know Y for steel is equal to 200 gigapascal, or more simply 2 into 10 raised to power 11 Newton per meter square. Now on substituting the values, I will get 2430 into 1. Here I will write as area of cross section 0.065 into 10 raised to power minus 4 into the Young's modulus of steel, which is 2 into 10 raised to power 11. So on solving this, I will get the delta L to be 1.87 into 10 raised to power minus 3. Or more simply, I can write it as this is meter 1.87 mm, which is the desired answer.